Today we will discuss about this problem. In all the cases, you have to calculate the magnetic field at O point. So, how to calculate this magnetic field? By using Biot-Savart law, you can easily calculate the magnetic field at O point. Now, this is the two formula. These two formula have been deduced by using Biot-Savart law. This formula is due to the current carrying wire magnetic field at O point at a distance d from this wire is given by mu0 by 4 pi I by d sin theta 1 and theta 2. This is theta 1, this is theta 2. And the direction of the magnetic field, this is my right thumb. So I move my forefinger towards d along the direction of d, and the magnetic field, this finger will give the direction of magnetic field. So this is the way, so it is inward. So for this case how to calculate magnetic field? So this is theta, we have to calculate the magnetic field due to this portion of this wire. So magnetic field at O point due to this portion of wire is given by mu0 by 4 pi theta I by r. The direction of the magnetic field at O in this case can be calculated in this way. This is my right thumb, so my forefinger is moving towards the direction of current. Okay, so this thumb finger will give the direction of magnetic field. So the direction of magnetic field is here outward, and in this case this is inward. Now by using these two formula, we can easily calculate the magnetic field in all these cases. So this is the two formula. Another is B0 equals to mu0 by 4 pi and theta I by r. This is the two formula. By using these two formula, we can solve all the problem. Now number 1. Here this is the smaller semicircle, this is the larger semicircle. This is the straight portion of the wire and this is the another straight portion of the wire. So magnetic field due to the straight portion of this wire, that means magnetic field for the portion AB and magnetic field for the portion DE must be equals to 0, since when this is the current carrying wire, if the point is pointed in same direction and upward or downward, both the cases magnetic field must be equals to 0. By using this formula, this is theta 1 will be plus 90 degree and theta 2 plus 90 degree and theta 1 minus 90 degree. That's why both the cases magnetic field will be 0. So for this two portion, magnetic field at O point is 0. Now magnetic field for larger circle at O. So magnetic field due to BCD, this portion, is given by this equation. So mu0 by 4 pi, this angle is pi, so it will be pi I by r. The direction of the magnetic field, this is my right thumb, so it will be inward. So if I take, this is minus k cap, this will be inward. I have taken that this is x-axis, this is y-axis, and along this is z-axis. That's why the direction of the magnetic field due to the larger circle is given by minus k cap, inward. Okay. Now this will be mu0 pi will be cancelled out. So mu0 I by 4 r. The direction, this will be larger capital R. Okay, this is capital R, so it will be capital R. So direction will be minus k cap, that means inward. Similarly, the magnetic field due to this point, this portion. So magnetic field due to EF A portion is given by mu 0 by 4 pi into this also will be pi by small r, because this angle also pi. So it will be pi I by small r. What will be the direction of this magnetic field? This is my right thumb. So if I move the direction of magnetic field, it is inward. Okay. So in this case, the magnetic field is inward. So here it also minus k cap, that means it is inward. So all the magnetic field is inward, that's why total magnetic field at O is given by the resultant of these two magnetic field. These two magnetic field are in same direction, so you have to only add it. So this is mu 0 I by 4r, and this will be plus mu 0, this will be pi cancel out, so mu 0 I by 4 small r. Both the cases the direction is negative z axis, that means inward. If you take common term is mu 0 by I by 4, it will be 1 by r plus 1 by small r. This will be minus k cap, that means inward. Okay, so this is the problem number 1. Now I will solve this problem. What will be the solution of problem number 2? This is very simple problem. Now this angle is 90 degree. So what will be this 90 degree? That means it will be pi by 2. So what will be the angle? This angle will be 2 pi minus pi by 2, that will be 3 pi by 2. So the direction of the current is along this direction and current is along this direction. So there is 3 portion of this problem. This is A, C, this is B, suppose this is O. So magnetic field, problem number 2. So magnetic field for portion BO, magnetic field for the portion BO and OA, and magnetic field for OA. These two magnetic field, here this point is the upper point of this straight line and this is the lower portion of this straight line. So when the point is here or here, then the magnetic field both the cases is 0. That's why in these cases this magnetic field must be equals to 0. Now what will be the magnetic field for this portion? That means ACB. So magnetic field for ACB portion, it will be mu 0 by 4 pi. We can calculate it by this formula, 4 pi into theta by r, theta I by r. What will be theta? This is the theta, 3 pi by 2. So it is 3 pi by 2 into I divided by A. This is A. The direction of the magnetic field here in this way, so outward. So this is k cap, that means it is outward. So in this case it will be mu 0 by 4 pi into, this will be 3 pi I by 2a. So pi cancel out, so it will be 3 mu 0 I divided by 8a. Okay, k cap, along the direction of k cap, that means outward. Okay, so this is the solution of this problem number 2. Now I will solve the problem number 3. Here you see, this is the curved portion, okay, and this is the straight line portion, A and B. So we can easily calculate the magnetic field for this portion. This angle will be 2 pi minus 60 degree. So 60 degree means, what will be 60 degree? 60 degree means pi by 3. So it will be 2 pi minus pi by 3. So it will be 5 pi by 3. So magnetic field due to the ACB portion can be calculated in this way. So what will be the solution of problem number 3? So this is problem number 3. So magnetic field due to ACB portion, okay, ACB portion is given by this equation, mu 0 by 4 pi into theta I by r. What will be theta? 5 pi by 3. So it is 5 pi by 3 into I divided by r. This I is upper portion, okay. The direction of the magnetic field is inward. This is the rule. This is inward. So it is negative k, negative z axis. That means inward. So it will be mu 0 by 4 pi. This is 5 pi I by 3 r. This is minus k cap. So this is pi cancel out. So it will be 5 mu 0 I divided by 12 r. This is 12 r. So this is minus k cap. Okay. So magnetic field due to this ACB portion is given by 5 mu 0 I by 12 r and direction is inward direction. Okay. Now you have to calculate the magnetic field at O point due to this straight wire. Here you see, this is 60 degree. That means AOB triangle is equilateral triangle. So this triangle is equilateral triangle. Okay. So this angle must be 30 degree and this angle must be 30 degree. So if this is a equilateral triangle, we can easily calculate the height of this triangle. Okay. So using this formula, we can easily calculate the magnetic field for AB portion at O. AB portion. What will be the magnetic field? Using this formula, mu 0 by 4 pi into I. This is the distance. What will be the distance? OD. This distance can be calculated by using formula the height of the equilateral triangle, root 3 by 2 into the side of this triangle. Side of triangle is R. So this is R into, it will be sine 30 degree plus sine 30 degree. This is sine 30 degree. This is sine 30 degree. So it will be mu 0 by 4 pi. This will be 2I divided by root 3 R. This is 30, that means half plus half. So it will be 1. So here it will be mu 0 I by this 2 cancel out. So it will be 2 root 3 R. This will be 1. The direction of the magnetic field also inward because the direction of current is along this direction. So using right hand thumb rule, so direction of the magnetic field for this AB portion at O point is inward. So this is also minus k cap, that means inward. So the magnetic field, total magnetic field is given by summation of this two magnetic field, two portion of this magnetic field. So total magnetic field is given by total magnetic field at O is given by this two portion, that means 5 mu 0 I divided by 12R plus mu 0 I by 2 root 3 R. Okay, and direction must be equals to the negative z axis, that means inward. Okay, so if you can take this common term mu 0 I divided by 2R, so in this case it will be, this is also a pi, this is also a pi. Okay, this is pi, this is pi. Okay, so in this case this also a pi. So in this case it will be, here will be 5 by 6 plus it will be 1 by root 3 pi. Okay, this will be 1 by root 3 pi. So this is the total magnetic field at O point for this portion of the current carrying wire. So this is the solving of problem number 3. Now I will solve the problem number 4.